Okay, so before we start on the quantum mechanical model, it's important that we reflect on what we have covered and what we do know up to this point. So Ernest Rutherford performed the Goldfoil experiment. He discovered the nucleus at the center of the atom, that electrons orbit the outside of that nucleus in the atom's mostly empty space. Well, he had a student that worked in his lab with him by the name of Niels Bohr, who discovered that the electrons aren't merely orbiting anywhere they want to, but they are actually in these distinct energy levels or energy shells outside of the nucleus, and that the further you get out from the nucleus, the higher the energy of the electrons are, okay? Lower close to the nucleus and higher further out. And he discovered this using emission line spectra. Now, as we move to the quantum model, you have to realize that these energy levels that Bohr discovered were accurate, like this was a thing. However, we're going to see that within each energy level that there is a lot more going on. So consider this about Bohr's model. So Bohr established that there were energy shells. So just imagine, like in Bohr's model, the energy shell is like this just circular ring, and that's the way that it's depicted in Bohr's model. But we have to realize is that we do not live in this just two-dimensional world. We live in a three-dimensional world. So just consider the three-dimensional space around the nucleus. So right here I have the energy level written. So energy level 2, these are the two different ways that we've seen an energy level written, okay? So it's either N equals 2 or E2, all right? So what I've done is I've kind of shown you how this is a three-dimensional drawing, that this is actually a sphere. So within this energy level, what was discovered with the quantum mechanical model is that they are not these just circular orbits, but that you actually can't know exactly where the electrons are, but there are probable locations with these distinct energies where you can find electrons. So there's actually a lot more going on inside of each energy shell. There's actually what is known as a sublevel within an energy level, and then there's also known as orientations. All right, and then there are spins. Now, I know that this is going to sound very foreign to you right now, but we are going to get into the details of each of these things. So, energy levels were discovered by Bohr. The rest of these things got uncovered with the development of the quantum mechanical model. All right, so going back to the history of the atom project, we learned that there were a number of scientists in the 1920s that helped develop quantum theory, and this all kind of piggybacked off of Bohr's idea of energy levels, okay? So Louis de Broglie determined that electrons really just kind of behave like waves, and then Heisenberg's uncertainty principle discovered that you cannot know the exact location of an electron. You cannot know its location and its speed at the same time, its velocity. And then, of course, Schrödinger, who got credit for actually developing the quantum mechanical model, said that although we know that these electrons have these discrete energies, knowing where they are in that electron cloud within their orbital at a given time cannot be known with certainty, and there can only be probable locations known as atomic orbitals. So we're going to take a look at these orbitals, or these in terms of how they make up an energy level. Okay, so I'm just going to start by showing you a quantum model. Okay, so this is going to seem a bit overwhelming, okay, but just kind of follow with me as you can on this, all right? So you've got the nucleus dead at the center. You can't even see it. It's so tiny, really. So you've got this is a quantum model of sodium. So let's talk about sodium. Sodium is number 11 on the periodic table, which means it has 11 protons and 11 electrons. Now, right now, we're only concerned about electrons because the quantum mechanical model is designed to give us an idea of the arrangement of electrons within a very complex model. So first of all, you'll notice you've got this S, or this P. You're seeing these letters, and it's like, well, what happened to seeing energy level 1, or seeing energy level 1, or energy level 1, or energy level 2, okay? Well, there's more to it than just the actual energy levels. There's actually more stuff going on within the energy level, all right? So first off, energy level 1, and you may recall this from physical science days, but the first energy level of any atom, can only hold 2 electrons. So right here, this is known as energy level 1, okay? Now, it's a 1s orbital because every energy level starts with what is known as a spherical shaped orbital. So if you see an S, that means sphere. All right, that stands for the shape of the orbital that the electron is most likely in. Well, energy level 1 only has sphere-shaped orbitals. It's the most basic orbital, and so energy level 1 only has a sphere in it. So each orbital can only hold 2 electrons. So this kind of makes sense since energy level 1 only can only hold 2 electrons. Now, so right here we see energy level 2. So that 2 is referring to energy level 2, but there's an S and then we see a P. Well, it turns out that energy level 2 has what are known as dumbbell-shaped orbitals. So it's got a sphere-shaped orbital and it also has a dumbbell-shaped orbital, okay? Now, the dumbbell shape basically looks kind of like a figure 8, all right? So you've got energy level 2 that begins with its 2sc, so it's further out. So this is what we're used to seeing in Bohr's model. However, we have to realize that there's not just these spherical shaped orbitals, but there's also more complex shapes going on. So basically, in energy level 2, you have a sphere-shaped orbital, which is this one. So this is a 3-dimensional circle right here, X, Y, and Z plane. Then you've got these dumbbell-shaped orbital as well. So right here is a dumbbell-shaped orbital in energy level 2. Here, that's on the up and down, the Y plane. Then you've got one that's on the X, and then one that's on the Z, okay? So yeah, this is starting to get complicated, but it's important to know that when we get into energy level 2, that there is actually a spherical shaped orbital, and then there is 3 dumbbell shaped orbitals, one that's on the Y, one that's on the Z, and one that's on the X plane. So when you take all of these and you overlap them, that's what we see created in this image. All 4 of these orbitals make up energy level 2. So, and yes, this is going to be very complicated at first, so I'm not going to deny that. All right, we'll be going over this more so tomorrow. All right, so the thing is, once you start getting out to further out energy shells like energy level 3, it even gets more complicated. Energy level 3 has spherical shaped orbitals, dumbbell shaped orbitals, and then they have what are known as the D-shaped orbitals, which are called the dumbbell donut shaped orbitals, all right? Now, a dumbbell donut looks like a P-shaped orbital, and you don't see that image in here because sodium doesn't have to go all the way out to the P or the 3P or 3D. So you can see that here's my energy level. Every energy level starts with the S orbital, every single one. So this starts with the energy level 3 sphere. So you can see that every single energy level starts with their sphere. Then it's going to move to the dumbbell or say the dumbbell donut. Now, the dumbbell donut, as I was mentioning, looks like this. It's kind of weird looking, but it looks like the P orbital with a donut around it, basically. Now, okay, so you guys are going to get an image of this tomorrow in class, but basically you have this buildup. That is, just like Bohr was saying that as we go from closer energy shells to further out energy shells, that energy is increasing. Well, within the energy level, there are these sublevels, the ones that I was just mentioning, S, P, D, and then we'll run into F, which is called your fancy orbital. But these sublevels also, and you can see that here, that sublevels, as we go from S to P to D to F, the energy associated with that sublevel is increasing. So what I mean by that is, say, consider energy level 2. If an electron is in an energy level 2 in a sublevel S orbital, then the energy that the electrons here that are in this orbital are lower than, say, the electrons that are energy level 2 p orbital. So an electron here is going to have higher energy than the s orbital, okay? So over here, this is kind of fanning out the so you can see over here in this image, you've got the nucleus, and then here's energy level 1, which is a sphere-shaped orbital. Energy level 1 does not have any other type of orbital. You can see that right here. Energy level 1 only comes with an s orbital. Well, energy level 2 comes with an s orbital, and then it comes with the 3 p orbitals, which you can only see pieces of these 3 orbitals just simply because this way the image is designed. When you get to energy level 3, you have not just your sphere, but you also have the p orbitals, the 3 different p orbitals, and then you start to have d orbitals, okay, the dumbbell donut. You get all the way out to energy level 4, you get all 4 types, the s, the p, the d, the f. Important to realize that the energy is increasing as you go through the more complex orbitals, and electrons will fill the less complicated ones first. It will always start with S and then move out to the D's and then fill up the D's and then go to the F's, okay? So there is a buildup in terms of, or an order in which we fill the orbitals with electrons, all right? Now, something to understand is that when you're in an energy level, so let's say that you're in energy level 2, there's only going to be one s orbital, whether you're in energy level 1, 2, 3, 4, 5, whatever. But p orbitals, there's actually 3 of them. And so that's why you see all 3 of them right here. And I'm going to switch to another slide so you can see that. So this image shows you the different orbitals. So the s orbital is always your most basic orbital, and energy level 1 only has an s orbital, okay? And then energy level 2 has an s orbital. Then energy level 2 also has the 3 p orbitals. Now, why is there 3 of them? Because a p orbital can rest on the 3 different axes. That's going to be your x-plane, your y-plane, and your z-plane. So you've got electrons in this one, electrons in this one, and electrons in this one. Now, the thing is each one of these orbitals, like this, each individual orbital can hold 2 electrons, okay? That's it. So each orbital holds 2 electrons max. That's what it will hold, okay? So it's important to know that as you fill as 2 electrons, let's say that you have you will have electrons, 2 electrons that will go into, you will have 2 electrons that will inhabit this orbital. My pen is being weird. And then you'll have 2 electrons in here, 2 electrons in here, 2 electrons in here. And so, and then once that fills up, they'll go to the d orbitals, okay? So it's always, electrons will always inhabit the lowest energy state orbital first and then move out to the higher energy state orbitals. And this is called the Aufbau principle, which we'll talk about. Now, so 2 electrons in each. So realize that once you get to energy level 3, you not only have, in energy level 3, you have an s orbital. In energy level 3, you have all 3 of the p orbitals, and then you have the 5 d orbitals. So they actually have 5 different orientations. So there's 5 orbitals. So I don't want to overwhelm you with all this talk, but it's just, this is to preview you guys on the complexity of what we will be doing, okay? So you can see it gets extra complicated, but especially in comparison to Bohr's very basic energy shells that were just circular orbits. But however, we are going to master this by following the same procedure every time. Like, there is a way to actually do this, and it makes a lot of sense. So do trust me on that. So tomorrow, in just a second, I'm going to switch slides. So tomorrow in class, we are going to really focus on how we will take a look at how the electrons are in a particular orbital, and again, it's always going to be a pair up to 2 electrons in each orbital, how one spins clockwise and one's going to be spinning counterclockwise within that orbital, and then that orbital has a certain orientation in space, like the y, x, or z plane. And then that orbital has a certain shape, and the complexity of the shape is associated with an increasing energy. And of course, all of these orbitals are going to be inside those energy levels that we were talking about when we were covering Bohr's model.